Here we have a short page of notes introducing the concept of resistivity and its corresponding but inverse notion of conductivity. Now, we said that Ohm, on our previous page of notes, that Ohm experimentally found that long, thin wires makes a large resistance. And he actually did experiments to show that they are directly proportional. So in other words, if you double the length of the wire, you double the resistance. If you decrease the area, then you increase the resistance directly proportional to 1 on the area. Once you have this direct proportionality, we play that same game we have seen with the math, that the proportionality becomes an equality with the proportionality constant, in this case the Greek letter rho, which we are going to define as the resistivity for a material. So resistance equals resistivity, length, times area. And we want to think of resistance as being directly related to each of them. So in other words, if we double the resistivity, you double the resistance. So the larger the resistivity, the larger the resistance, the less it will conduct. Well, we know copper is a pretty good conductor, and copper has a resistivity of 1.6 times 10 to the minus 8 ohm meters. And speaking of units, before we talk about the numbers, ohm meters, hopefully that is seen to be correct because R is in ohms, so there's our ohms. Length is meters, area is meters squared, so we take the 1 meter we're left with on the bottom here, bring it up with the ohms, we have ohm meters, so resistivity has units of ohm meters. And again, the larger the resistivity, the larger the resistance. So copper has a slightly larger resistivity than silver, but if you notice, not a lot, 1.68 versus 1.59, and silver obviously would be much more expensive than copper, so that is why silver is not used. Now, the last bit of notes on this page is simply to note that conductivity is the inverse, directly the inverse of the resistivity. We will not be using conductivity in this class. We will be using resistivity, rho. Conductivity, sigma, the Greek letter sigma, as it says here, is often used by chemists who specialize in material science. So material scientists will use conductivity quite often, and as well as solid state physicists. So physicists that actually look at the type of physics that we're doing, but in much more atomic and molecular detail. So there you have our very quick page of notes. So I'm zooming back out. Pause it and make sure your annotations are complete, and we will move on.